That's one small step for man, one giant leap for mankind.
If they weren't part of our history, these raw, grainy television recordings of Neil Armstrong's giant leap for mankind would have disappeared into the archives decades ago.
And they had this type of equipment, for example, a Hasselblad camera, to take shots of the moon surface, basically panorama shots, shots of the landing vehicle, shots where they took photos of themselves.
Nevertheless, the first men on the moon opened the door for something as modern as 3D photography by using two cameras.
We'd like you to leave immediately.
Since that 21st of July 1969, science has taken a few giant leaps as well. High-definition images have become the standard, even on the International Space Station. Every second of a space mission is documented by a multitude of cameras, from liftoff to landing. If anything should go wrong, a problem can be analyzed more easily if pictures are available. Inside the International Space Station, astronauts use a dozen different cameras as they conduct experiments, communicate with the control room, or just want to impress us back here on Earth by showing how nice it feels just to float by. But in most cases, cameras in space are part of work. The Erasmus recording binocular may look a bit funny, but the 3D images of this camera are absolutely amazing. The combination of this 3D footage and normal 2D images enables astronauts to practice their future work in the ISS down here on Earth.
It gives the opportunity to do actually a mapping of the station, so that on ground we can build a 3D model of the station in the computer and use it, for example, in virtual reality studios to see how certain payloads can fit into one or the other area.
For unmanned missions like that of the Mars rover, the cameras on board the vehicle are the eyes of the scientists and engineers in the control room. Because the images are in stereo, much more information about the surface or obstacles can be gathered from them than with conventional images. Spectacular images of spacewalks, for example, or three-dimensional video visits to the space station play a key role in catching the attention of the general public. One of ESA's main goals is to attract young people, particularly students, to scientific disciplines. And what better way to do so than to show them where science can take you?
I think there is nothing that can really replace seeing something with your own eyes. But still, I have to say now, after this mission, when I see the images I took myself, it's still impressive for me and it reminds me how it was there. So I think really it is as close as you can get to reality.